My project about trigonometry, the history of trigonometry, it started with the Egyptians when they tried and did build a pyramid, but they were trying to figure out the sides and the missing sides after a while. The Greek got the theory and changed it, and the scientists made formula. It was Heron's formula. The Pythagorean theorem is named after the Greek mathematician Pythagoras, who by tradition is credited with its discovery and proof, although it is often argued that that knowledge of the theorem predates him. Special right triangle is so important. It is important because if we have a special right triangle, which is an isosceles right triangle or something else, isosceles right triangle is 45, 45, 90 degrees, the other is 30, 60, 90, and then you have two different formulas depending on which right triangle it is. You can find the missing side. Special right triangles, isosceles, 45, 45, 90, scalene, 30, 60, 90. Pythagorean theorem, if we know the length of two sides of a right angle triangle, we can find the length of the third side. But remember that it only works on right angle triangles. When a triangle has a right triangle 90 degrees and squares are made of each of the three sides, then the biggest square has the exact same area as the other two squares put together. A squared plus b squared equals c squared. Trigonometry ratios, um, sine opposite divided by the hypotenuse, cosine adjacent divided by hypotenuse, tangent opposite divided by adjacent. Um, and you also have to remember the Sahota. Probably edit that out because it's not going in. Labeling triangle parts, anything right across the right angle is the hypotenuse and the others are legs. When do you use this inverse? The usage of inverse comes in where you have the side lengths and you need to find the angle measurement. You could use the inverse, sine, cosine, and tangent. These allow you to find an angle in a right triangle. How to use a calculator to find exact measurements. Well, give me a minute. No. To find the side measurement, you have insert trig ratio. Basically, insert the angle measurement, then insert the side measurement, and that's how you get the side measurement. To find an angle measurement, you have to insert trig ratio to the power of -1. Basically, insert the side measurement and then insert an angle measurement. That's how you find an angle measurement. If using a calculator, there is a simpler way to do it. To calculate the sine, the sin, cos, and tan keys, and then just enter the sides and the measurement. You have to find You have to find the answer. When do you use inverse? Already said it. Um, the relationship between trig is, where is it? Relationship between trig. Why did I stuff out, yo? If one of the angles of a triangle is 90 degrees, a right angle, the triangle is called the right angle triangle. You indicate the 90 degrees right angle by placing a box in its corner, because the three internal angles of a triangle add up to 180 degrees. The other two angles are each less than 90, that is they are acute. Uh, um, the applications of trig ratios could be used for construction. Could be a very hard job when it comes to math. Trig ratios could be used for a job on construction. For example, constructing a building requires a lot of trigonometry and especially trig ratios. If a large building such as a school building could be working on stairs, one may have an angle measurement and also one on one side measurements and could be looking for other measurements. That's where trig ratios come in handy. Applications for trig 2. One may want to put frames on the wall. They want to use the drill to clip it on the wall, but before they do that, they decide to measurement the wall to see if they get the right size frame so they could put it on the right place. Application of trig 3. One could want to find the measure of a box in order to put the right size of shoes in the box. Conclusion is that humans have been using angle way back in time to find simple measurements, and it really introduced us to mathematics subject from simple geometry to trigonometry. And not only we use that in class, but we use that in real life situations, because triangles are everywhere around us, buildings and statues. We're constructing by studying and identifying the angle to make it stable.